Hi, my name is Bob Beechell. Now in this video on using R, I'm going to be looking at one of the key objects in R, that is a list. Now a list is a sort of special type of vector, but the key point is that the components, unlike a normal vector, can be of different type. They can be a mixture. In fact, a list can also contain another list. Now, one particular important use of lists is to return the results of some statistical procedure, and that's probably the main way in which you'll come across them. So let's look at how to create a list. This is the syntax. You use the command or function list, and then in brackets the various components. Each component is given a tag to identify it, which can then be later used when you're accessing elements. So here I'm creating a list which I'm assigning to the variable mylst. It contains a character vector here with two elements. The tag here is name. A single vector, a single component numeric vector with one component 60 and tag name h, and a single component logical vector with the tag name retired. So notice how this is written. You have the tag name equals and then the component. So if I enter that command with command enter or control enter, of course, on Windows, and then print it out, as you can see, it lists, forgive the pun there, the elements, the vector here, character vector, this numeric vector, this logical vector. I notice that the tag names are listed with a $sign, which, as we'll see, is how you access them. Now if I run the structure command on this list, again we can see it has exactly what it is. It's a list of three components. Here's the names, the tags of the components, and here are the components. The summary command here, which I've used before, doesn't really give you very much useful information on a list. I'm not going to run that here. The length command simply tells you how many elements are in there. Now, let's look at subsetting and filtering. In other words, how to access individual components of a list. Now, you can do that with by using the tag names. And as you can see here, what you do is you put the variable name, a $sign, and then the tag name. So effectively you put the same as is here. So this should access the name component, which of course is a character vector to component, so it returns that as a vector. Here's age, that again is returned as a single component numeric vector. Now what about the other component, retired? Well, I'm actually going to, I haven't typed that in yet because I'm going to show you how, in fact, a couple of neat little shortcuts in RStudio for typing variable names and components of lists. If I start typing the variable name here, then as soon as you've typed in sufficient letters so it can recognize which variable you're talking about, it keeps a record of all these, of course. It will pop a dialog box, a little box, showing a list of possible variable names. In this case, there's only one. Just choose the one that you want and just press enter. So that saves you time in typing in variable names. Now, if I then type a $sign, as you can see, it pops up a list of the various components in that list, which again is a very neat time saver, and it means you don't have to remember all these components. So simply choose the one you want, here retired, and enter that with command enter, of course, and it returns that vector, that logical vector. So notice how using this notation, the $sign and the tag name, returns the elements in the form that they were entered. If, however, you wanted to return one of the elements as a list, you can use that using this notation here. So again, the variable name mylst, then in square brackets and in inverted commas the tag name. So this will return this vector here, but it will return it as a list with that element as its as one of its elements, or its only element in this case. So let me run that. You'll see what I mean. So this time, you notice the difference. It's returning a tag name and then the vector. So in other words, it's returning it as a list with one component with this tag name. So normally you probably want to return the component in its original format, in its original mode, but sometimes you might want to return as a list themselves. Now let's consider how to add and remove components. This is very straightforward. If you want to add an additional component, you again use the dollar notation. So here I'm going to add an additional component with a tag name pension, and I'm going to give that a value of 2000. So in other words, I'm adding a one element vector here. So let me enter that. If I now print out my list again, mylst, as you can see, that has been added as an additional component with this tag name. If I want to remove component, I simply assign the value null to that component. So if I want to remove this component here, retired, I simply assign that the value null. Notice the difference here. When I was adding a component, I used equals to indicate what I wanted to add. Here I use the assignment operator to assign null. So assigning null will, as you see, remove that component. So that's basically how you use lists. But in fact, most of the time you'll come across lists as when you are returning the results of a statistical computation. If you run a linear regression or some other statistical operation, the results invariably are returned as a list. And you can then access the elements of the list, the individual results within the overall list of results, using this notation, this way here that we've looked at. Now to illustrate this, I'll run a simple regression and illustrate that. Now we'll be looking at in detail at how to run regressions in a later video. Here I'll quickly run through it and then show you the list that's returned. So first of all, I'm going to load up a data set from this particular package, AER. So that will load this data set here, CPS 1988, which has got a whole range of variables in it. It'll be entered, it'll be a data frame, and then when you import data into R, it becomes into a data frame, which we'll be looking at in the next video. I'm then going to create a model to run a regression equation. I'm then going to run that regression, and the results of that using the LM function, which is the standard function for running linear models, linear regressions. I'm going to store the results in a variable model1, and this, in fact, is a list. This contains all the results as a list, plus addition information and so on. To see that it's a list, let me run the structure command here. And in fact, you get a whole lot of stuff here showing how many actual components there are. If I scroll back up, you'll see it is a list. It's a list of 13 components. Here are the tags showing the components, which you can access, of course, using the way we've looked at here. So if I want, for example, to access the coefficients of the coefficients of the variables, the estimated coefficients of this model, I can use the notation here. Model1, of course, is the variable name, $, and then coefficients. Of course, if I was typing this in, then of course, as we saw up here, once I put in the $, a list would come up with all these components or these tag names, you could choose the one you want. So I'm going to store that in a variable z. Let's print it out. And as you see, we've got a vector here with the estimated coefficients of the intercept and the independent variables. Notice, in fact, that what we've got here is a vector with names in. It is possible to name the components of a vector, the elements. I haven't looked at that before because normally it's not something that you would do. Now the names here are optional. You don't have to include them, as we've seen before, and they don't in any way affect using the vector and in the ways that we've looked at previously. You access the components in exactly the same way, and you can manipulate them and carry out the same operations and so on. I'll illustrate that by accessing the first element here. So using the standard subsetting notation, that accesses, of course, the first component, intercept. This will access the second one. And to demonstrate that the names do not interfere in any way with operations, I'll add together the third and fourth components here. So let me add together Z3 and Z4, which is the addition, is those two added together. Notice, in fact, it does then use the name of the first of the components there here. Now, if you want to remove names from a vector, so this operation, of course, would return a vector, with this single element. If I wanted to remove that name here, or if I wanted to remove all the names from this one, you simply assign the names of the vector to null, and you do that here. So you use the command names, in brackets, the variable containing the vector, and then assign a value of null. So that's telling it to assign null to the names, in other words, remove them. So if I run that, and then print out the Z again, as you can see, the names have been removed. Okay, so that's a quick run through of using lists in R.